Welcome to Game Mechanic, a series where I'll examine different game mechanics and recreate them. The first game mechanic we'll be looking at is the Trapwire ability in Valorant. This ability allows a player to place a wire that traps enemy players when they come into contact with it. The Trapwire ability has 3 stages: deploying the trapwire, trapping the player that touched the wire, and then finally concussing the player after a certain amount of time. In Valorant, the trapwire is set up by placing one end of the trapwire on the object the player is looking at, and then the wire is extended until it hits another object, but the wire can only be extended up to a maximum distance. First, let's get the look of the wire down. Valorant uses a 2D texture instead of using a 3D mesh of a wire, since 2D textures are more efficient to render. The 2D trapwire texture uses a technique called billboarding to make the texture always face the camera. But after struggling to figure out how to get a 2D texture to always face the camera in the direction I want, I just decided to use a 3D mesh instead. Visually, Cypher has a CCTV theme. His trapwire kinda looks like TV static, and so does his cage ability, and also his main ability is a camera. I create a shader of repeating blue bars with rolling emissions, and then I use a sine function with time as a parameter to make the rolling emissions. I use a max function to floor the output of the sine function, since sine function's values go from -1 to 1, and color intensity is represented from 0 to 1. Next up is setting up the trapwire to be deployed. To do this in Godot, we simply need to have a raycast point towards wherever the player camera is looking. When the raycast hits an object, that is where one end of the trapwire will go. The wire will then be extended away from the surface of the object. The wire shader has a wire length parameter to adjust the wire length when it's deployed. There are infinite directions pointing away from a surface, but the one direction we want is a normal vector. A normal vector simply means the up direction of a surface. If Cypher is on the ground, then the normal vector points up. If Cypher is on the wall, then the normal vector points sideways. Once the trapwire is deployed, it will be invisible until an enemy player gets very close to it. Hard to trick someone with the wire if they can see it from afar. In Valorant, there is a low buzzing sound that plays when you're near the wire. I implemented this by adding a player detection area around the wire. The Trapwire script will then modify the wire's transparency based on the player's distance. For the audio, I use a 3D audio stream player node and had the node always be at the point on the wire that was closest to the player. To activate the trap part of the trapwire, I added another area to the trapwire that is the same shape as the wire. Once the trapwire is activated, the wire will disappear and 2 cones will trap you. Something I forgot to include in the first draft of the video is how I got the cones to follow the player. Initially, I tried calculating the rotations needed to rotate the cones to follow the player, but that got complicated pretty fast. I found it much easier to learn how to use the basis of an object to make it follow the player, and would recommend anyone trying to rotate an object in Godot to learn this too. The cones show more details of the trapwire shader, such as a moving TV texture that has a staticky effect. I like how the shader came out on the cones. It feels as if the cones are luring the player into the TV effect.
Cool. What do you think, Finn? Can we pull back the veil of static and reach into the source of all being behind this curtain of patterns, this random pattern generator? So clever. Right here in every home, watching us from a one-sided mirror. Whoops, just wizard.
To trap the player, I say the location the player touched the wire, and I call this the anchor point, and then in the player's movement code, I prevent the player from moving a certain distance beyond that anchor point. In the player movements code in each physics frame, if the player moves beyond the maximum distance from the anchor point, the script will use the direction of the anchor point to the player as a vector, and then set the length of that vector to the maximum trap distance, and then set that as the player's position. The final stage of the trapwire is to concuss the player, but instead of doing that, I added a rolling TV static effect that makes it harder for the player to make out what's happening. I did this by adding a post-processing effect by covering the screen with a 2D sprite that redraws the screen but then applies a shader to it. And that's my Walmart brand Cypher Trapwire.